Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shahroz Abdullah and today we are going to discuss numerical problems of chapter number 11, sound, class 10 physics, right? Let me recall the previous work that we have done. If you remember, in the previous work we have done with audible frequency range, we have discussed infrasonics, we have discussed ultrasonics, right? We have discussed the applications of ultrasound or ultrasonics in our daily life. Now what we are going to do today, today we are going to do with the numerical problems of chapter number 11, that is sound. Okay, let me read the first numerical problem. What does it says? It says the sound intensity 3 meters from a jackhammer is 8.20 into 10 to the power minus 2 watt per square meters. Look, intensity of jackhammer is given to you, that is 8.20 into 10 to the power minus 12 watts per square meters. What is the intensity level in decibels? You need to find out the intensity level in decibels, but use the usual reference level of intensity, that is 1.00 into 10 to the power minus 12 watt per square meters. Okay, reference level of intensity is given to you 1.00 into 10 to the power minus 12 watt per square meters. Okay, what we are required, intensity level in dBs we are supposed to find, means beta we need to find. Okay, from the formula that we have derived, we know that beta is equal to 10 log of I divided by I naught into dBs. Just put the values over here. When you put the values, you can have the answer. Look, 10 will be as it is. Instead of I will put this value over here. Instead of I naught, I will put in this value over here, standard value. Just use calculator and reach to this result. 10 will be as it is. When you find the log of this term and multiply with 10, you are going to get this value. So beta is equal to 109.14 dBs. So this was about question number 1. Okay, and question number 2, what we are going to discuss, it says that a ship is anchored where the depth of water is 120 meters. An ultrasonic signal sent to the bottom of the lake returns in 0.16 second. What is the speed of sound in water? You are supposed to find out the speed of sound in water. Okay, what is given to you? Look, depth of water is 120 meters. Is it clear till here? Okay, now time taken by sound to return del t value 0.16 meters. Then ho gaya? Okay, what is we are needed to find? Velocity of sound in water, means value of v we will find. Okay, from the definition of echo we know that v is equal to 2s by del t. Let me write del t over here, or just you can write simple t as well, no problem at all. Just put the values in this formula and get the result. What is the value? 2 as it is, formula wala. S is 120 and t value 0.16. Just use calculator and reach to a result of 1500 meters per second or 1500 meter per second. So this is your required result. Okay, now coming towards question number 3, it says a gunshot from a 22 rimfire rifle has an intensity of I is equal to 2.5 into 10 to the power 13 I naught. Okay, intensity of rifle is I is equal to 2.5 into 10 to the power 13 I naught. Okay, do we need to wear air protection considering that prolonged exposure of sound above 85 decibels can cause hearing damage or loss? Okay, reference intensity level, we know that I is equal to I naught is equal to 1.00 into 10 to the power minus 12 watt per square meters. Okay, what is the value of beta? We are supposed to find that value of beta. Intensity level is given by basic equation. We know that the basic equation we are having is beta is equal to 10 log of I divided by I naught into dBs. Just put the values over here and get the result. 10 will be as it is, log will be as it is. Instead of this I will write 2.5 into 10 to the power 13 I naught, and instead of this I naught which is in the denominator, we will write the value, we will write as it is I naught. This I naught will be finished with, cancelled out with the upper I naught value, like this I naught will be finished. What will be remaining terms? So beta is equal to 10 log 2.5 into 10 to the power 13. 10 will be as it is. Use calculator and find the value of log of 2.5 into 10 to the power 13. When you get the result, multiply it with 10, you are going to get 134 meters per second. So result is 134 meters per second decibels. And they are saying that for your information, they are saying that 85 decibels, like sound intensity above 85 decibels can cause hair damage. So if we get the answer of 134, so definitely it is going to cause a hair damage. Okay, so we should wear ear protection. Okay, this was all about question number 3. Now we are going to do question number 5. Okay, in question number 5, what is the statement? What is the speed of sound in air at minus 20 degrees centigrade? Look, this is the question statement. What they are saying in question number 5, temperature is given, that is minus 20 degrees centigrade. Okay, and speed of sound in air, V value we are supposed to find over here. And the formula for finding speed of sound at a given temperature, that is V is equal to 331 plus 0.6 into T, and V is equal to 331 plus 0.6 multiplied by minus 20, and you are going to get 319 meters per second or 319 meters per second. So this was the value of speed of sound. Now coming towards question number 6, let me read the question number 6 statement. What is said in the statement? Army men wearing binoculars see the flash from enemy's tank fire 5 seconds before the fire is heard. He records 26 degrees centigrade temperature on his personal thermometer. What is the distance of the tank from him? Okay, we are going to discuss question number 6. Time is given to you, that is 5 seconds. Temperature is 26 degrees centigrade. What is required? Distance of army men from the tank, means S value we are supposed to find. Now what we are going to do? Look, we will find first of all speed of sound value V, that is V is equal to 331 plus 0.6 into T for a given temperature, that is 26. So we find it out, like 0.6 will be multiplied with that 26. We are going to get 15.6. when it is added to 331, we are going to get 346.6 meters per second. This is the value of V over here. Now what is tip 2? For finding the distance of the army man from the tank, what we need a formula. We know that V is equal to S by T. By cross multiplication we are going to get S is equal to Vt. Just put the values over there and get the answer. S is equal to V value 346.6 multiplied by time value 5. Just multiply it and get S is equal to 1733 meters or 1733 meters. Done ho gaya. So this was all about question number 6. Okay, now we are going to do question number 7. Let me read the statement. What is question number 7? Calculate the wavelength of sounds at the extremes of the audible range of 20 hertz and 20,000 hertz at normal temperature of 20 degrees centigrade. Okay, what is said over there? Minimum frequency is 20 hertz, maximum frequency is 20,000 hertz, and temperature is 20 degrees centigrade. Done ho gaya? Okay, now we are required with the two of the things over here. The first is minimum wavelength, means lambda minimum we need to find. Second is maximum wavelength, means lambda maximum we need to find over there. Okay, let's come towards the solution. The first step we are going to do, first of all, find the value of speed of sound. We know that for a given temperature, speed of sound formula is V is equal to 331 plus 0.6 multiplied by T. Just put the value of T over here, which is temperature actually. So V is equal to 331 plus 0.6 multiplied by T value 20. Just multiply it and get V value 343 meters per second. Once you are fine with speed of sound value, now come towards finding the minimum and maximum wavelength values. As we know from universal wave equation, V is equal to F lambda, right? Lambda is equal to V by F. But do remember one thing, for finding maximum wavelength, frequency should be minimum. If you remember, in this formula wavelength and frequency are inversely proportional. So if lambda will be maximum, automatically what? Frequency will be minimum. Okay, V value is 343 and F minimum value is 20. Just divide it and get 17.15 meters. Done ho gaya? This was maximum wavelength. Now coming towards minimum wavelength, the same expression we will use, a slight change in it. Look, for a minimum wavelength, do remember frequency should be maximum. Okay. So lambda minimum is equal to V value 343 meters per second. Frequency maximum value is 20,000. Just use calculator and get 0.017 meters. You can convert it into centimeters as well. So answer will be 1.7 centimeters. Okay, this was all about. And now we are going to do question number 8. Let me read the statement of question number 8 first. It says Ishfaq stands between two high-rise building A and B such that he is at 33 meters distance from building A. When he blows the whistle, he hears the first echo after 0.2 seconds and second echo after 0.8 seconds. Calculate the speed of sound. Number 1, this is the first thing we need to find. Number 2, distance of building B from him. So this was the statement of question number 8. Now let's solve this question. What does it say? Distance of building A, S1 is 33 meters. First echo time is T1, 0.2 seconds. Okay, time for second echo T2 is equal to 0.8 seconds. And what is required? Two things we need to find. Number 1, speed of sound V value. Number 2, distance of building B means S2. We need to find. Okay, let's come towards solution of part number 1. As we know that for echo we write V is equal to 2S1 by T1. 2 will be as it is. Instead of this S1 we write 33 and instead of T1 we write 0.2. So V value will be 330 meters per second. This was about part A. Now let's come towards part B of it. To find the distance of building B, the same formula we use but 2 to the base. V is equal to 2S2 divided by T2. By doing cross multiplication we get 2S2 is equal to VT2. Dividing 2 on both sides, so we get S2 is equal to VT2 divided by 2. Just put the values over there and get the answer. S2 is equal to V value 330. T2 is 0.8 divided by 2. When you solve it by calculator you are going to get 132 meters. This was all about today's lecture. In today's lecture we have discussed chapter number 11, sound, all the numericals detailedly we discussed over there. Hope you have liked and enjoyed the video. Thanks for watching. Allah Hafiz. Fi Amanillah.